In this lesson, we're doing the opposite of what we did in the last lesson. So if you cruise through the last lesson, which you probably did, you're going to find this pretty easy as well. So I'll show you an example. We're going to go pretty quick here. I'm only going to show you one or two. But there's a couple different ways you can do it. I'm going to show you how to do it like we did it before. And then I'm going to show you a little trick that you can use sometimes. Okay. We're going to use the fact. You can use whichever one you want. You can say 360 equals 2 pi, or you can use 360 degrees, I should say, right? And 2 pi radians. Or you can use the sort of simplified reduced version, which makes your numbers a little bit smaller right off the bat. 180 degrees is pi radians. Okay, so we have 3 pi over 2 radians. And you probably just finished that last lesson. It was probably pretty quick and easy. So you're going to know how this is going, right? So I have radians. I can multiply by essentially the opposite fact as before. So pi and 180. So 180 degrees, and then pi radians would be my conversion factor here. And I know it's correct because radians is canceled out, and then the degrees is left over, which is what we want. Okay. Now, don't be tempted to type this into your calculator, because it's actually easier, at least for this first step, to do it by hand. So pi over pi cancels out. You get 3 times 180, or 2. And then there's a couple different ways we can do this. So I'd like to probably divide 180 by 2 and get 90. This is just 3 times 90 degrees, which is 270 degrees. Okay. So there's your conversion factor method. You could also set up a proportion like I showed you in the previous video. And again, there you're lining up your equivalent pieces. So whole circle across from whole circle, and then 3 pi over 2 across from x. And that's about it. So unit conversions like the last one. On this lesson, I'm going to show you a little trick. And I think this is kind of clever and elegant. So this was sort of method 1. Here's method 2. I'm going to say we're still using 3 pi over 2. I'm going to use the fact that pi radians equals 180 degrees as sort of a substitution. So I'm going to say this is equal to 3 times 180 degrees. So I plugged in 180 for pi. I would normally, I kind of don't like that because we know that pi is a number, not a variable, so we shouldn't really treat it that way. But in this case, it works because these two things are equivalent. And then notice we get the exact same situation as we have when we multiplied there, which is kind of cool. And again, the result is the same. We get 270 degrees. So method 2 is plug in. I'm going to even put that in quotation marks because I feel kind of weird. I'm going to call it substitute, actually. Substitute 180 for pi is this method. And it only works when we have pi in our measure. And we'll do just one more example because this is a slightly different type of problem. So notice this guy, 6 radians, or negative 6 radians it is. No pi, right? So what this tells me is that this is sort of a fractional angle. So I'm going to get a decimal because it's not a nice piece of this circle because the whole circle is 2 pi. So if there's no pi in this term, it's just not a nice piece of the circle. And it tells me to round to the nearest tenth, so that's going to give me a hint that I'm going to get a decimal here. Your work, so obviously we can't plug in 180 for pi. We can't use this trick like we did before. But your work can look really similar otherwise. So 6 pi radians times 180 degrees over pi radians. So my units cancel out nicely, and then I get negative 6 times 180 over pi. And here you need a calculator, right? So we're going to do negative 6 times 180. And then hit divided by pi. Make sure you keep your negative because negative 6 radians is a different angle than positive 6 radians. And then You divide that out, you get negative 343.775 and some change. This decimal will go on forever because pi goes on forever. Degrees, and then it says to round to the nearest tenth. So most of you are good at rounding now. 7 tells me to round up, so I get negative 343.8 degrees. Okay. So work is the same. Just note that when there's no pi involved in radians, you're definitely going to get a decimal in your degrees. Okay. So as you're doing these, you're going to do a few of these first, and then you're going to have some mixed problems where you have to convert radians to degrees or vice versa.